We're living through a period of enormous disruptive change. We can debate nuance of meaning and interpretation, but AI is here, and even if its advance stopped right now, what we already have is such a profound change and so disruptive that we will soon be living in a new world, a very different world as a result. For us software developers, we're at the forefront of this change. We are early adopters of the technologies, and we're already well attuned to using computers to supplement our efforts. My own view is that AI changes some of the detail of what we do day to day, but also refocuses us on what has always been important, fundamental, the core of our discipline. Learning about and building our understanding of a problem and then creating software to address that problem. But if you thought of your core skill as being the technical act of translating a detailed description of a solution created by someone else into working code, then I'm afraid you have a problem, because AI can do that now. And it can do it more quickly and more cheaply than we human beings can. That's a huge change alone. But where does it leave us? Welcome to the Modern Software Engineering channel. I'm Dave Farley, and if you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well, and why not join us in the comments to this, I hope, intriguing conversation. This is the first episode in a series of explorations of where we are and where we're going with the use of AI. We call this series AI Briefings, and our goal is to talk to people who are doing interesting things with AI-assisted software development in the hope that we can all better understand where we are going and how best to navigate the uncertain future that faces all of us. This episode is brought to you by our sponsors, Equal Experts, Transfig and Octopus Deploy, and through the support of our Patreon members. We'd like to thank all of them for their ongoing support. Our sponsors offer products and services that are extremely well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, do click on the links in the description below to check them out. So, welcome to this first episode of AI Briefings, and in today's episode I have been speaking with Mike and Alessandro, who are the creators of an open source AI development system called nWave. nWave currently runs on top of Anthropic's Claude, although there is some work to make it available on other platforms. It's an interesting take on how to take advantage of AI in assisting our development efforts. And I think it highlights one of the significant advantages of AI-based tools. They can work within guidelines, but can also be flexible in terms of how they do that. This means that nWave can aim to guide you through the whole software development lifecycle without being rigid, formulaic, or implementation technology constrained. So its advice isn't really about tools and technology directly, but rather about principles and fundamentals. This lines very well with my thinking and my approach, and I suppose that I should confess that Mike and Alessandro cited some of my work as some of their inspiration for their work on nWave. So I guess I'm naturally well aligned with their philosophy, so make of that whatever you will. But let's listen to Alessandro explain.
Basically, for people that are not used to our workflow, it would explain why you are doing some activities. Because with AI, you are tempted to just let it code, right? It can create so much code so quickly that it feels like a waste of time if you're not coding. On the other hand, if you have been a software engineer and not just a coder, as a software engineer, our biggest, most important responsibility is to understand the problem space and define it very well before we can even start thinking about the solution space.
I think this is an important aspect of how our role is changing. This has always been an important aspect of software development, and I'd say a property of great teams. But now this is even more obviously true because in large part we can leave at least some of the responsibility for the solution to the AI. Our job is to understand and describe in verifiable detail the nature of the problem that we're trying to solve. Mike and Alessandro describe this as behavioral engineering.
And that requires communication, understanding, humility, and also a good sense of what is important and what is not relevant. And so behavioral engineering is crucial in this because it brings, again, human at the center, people at the center. It doesn't matter how well tested is software that nobody uses. If you're solving the wrong problem or not solving a problem, it doesn't matter who even coded it, right? And that's when it makes all of the difference. But it goes a bit further because even in the ways we are describing the agents, we are careful. I created the agent exactly to review these kind of things so that it can review the language you're using. Because, for example, now just found out, but we already knew, that for some models like Opus 4.6, if you're using words like must or always or absolutely, maybe in capital letters, they over-trigger. Okay? And so we have to be understanding that on the other side, there's an entity that doesn't perceive reality like we did, but it's mostly a mirror with all the goods and bads. Right? So when we complain about bad code written by AI, well, guess on which code has been trained. And so on the other hand, there's also good code that is present in their training set.
This is an important point. The other important human role in the use of AI is providing the broad context for the development. This goes further than only simple behavioral requirements and is really into the much more subjective territory of good taste, things like architecture and engineering decision making, the things that matter depending on what we are building and why. A lot of people that I've spoken to about AI development so far, including me until recently, have largely been playing with it to help us to build simple single user applications for our own use. And it's very good at that. For very simple things like this, for simple systems, fairly lax vibe coding works absolutely fine. But if you're building systems that deal with other people's money or private information or other things of greater consequence, which as professional software developers we usually are, then this broader context of considerations starts to matter much more. Think about building a system like Twitter. Even without AI assistance, I could build a working version of a system that does the basics of Twitter within a small number of days. But as soon as I need to think about the fire hose of information to deal with this same problem at global scale, the nature of the problem changes profoundly and fundamentally. You can think about this as the kind of thinking a software architect does, but it's also a different kind of engineering problem and a different kind of problem to specify to someone or something else what it is that we need from the system if they're doing the implementation. Most of the code that AI will have seen will be small, simple, and relatively naive, because that's what most software in public looks like, with a few exceptions. So we will need to steer our AIs to more deeply understand the context of our work and guide them using our taste as engineers, architects, and developers in the direction of a suitable set of solutions. There is no one right solution for any system.
And so with our guidance in the definition of the agents, we basically maximize the probability that the next token that is going to be predicted is the one that is matching how we like things to be done, from architecture to discussing things to writing tests to implementing code. And so in this situation, this is something that makes a whole lot of difference, because really it feels like implementation, the coding part, which it can be almost completely automated. I wouldn't recommend to not look at the code and deploy to production. Okay.
Yeah.
But that is largely done today already with nWave. The difficult bit is to put in place a whole infrastructure that allows you to iterate quickly, because you will realize that even if you discuss things and you think that you understand the problem, and even if the AI implemented exactly what you meant, when you start using it, it's always kind of disappointing. We all know that, Dave. I mean, you have been leading this industry for decades, right? We all know that. That's why we do small iterations. no big
Yeah.
design upfront, no big bang releases.
Yeah.
This is even more crucial now. And
Yes.
that's why our approach is not, I would say, just spec driven, because spec driven reminds me of a waterfall approach that requires a lot of commitment from the get going. Instead,
it's kind of fine-grained, iterative, specification driven. Yeah,
exactly.
Microspec.
Yeah, yes,
exactly. I just refined the first wave to include elephant carpaccio. So the product owner agent will tell you, hey, this feature is quite big. Maybe we should split it in smaller features and develop one by one.
Yeah.
You know, what is the last time someone heard a product owner say, okay, now let's go slower. Okay.
Yeah.
But that's actually what it matters. Then you need to have your observability in place. You don't want to go to production completely blind. It's true. The AI can hold a lot of text and logs in its head, but you have to tell it to write those logs in the first place. Otherwise, you can have an outage, but it can last forever. And if you have to then dive into the intricacies of the code, good luck. But that's true whether you're using AI or not. And we have been knowing this for decades.
This is another vital point. Just because we can prompt an AI to generate lots of code in a single step doesn't mean that that's a good idea. Small steps are even more important for working with AI. This is true for many reasons, but not least because it's a vital part of software development that people often forget. It's that it's a process of discovery of the problem. And so, if we are to be any good at it, we need to have thoughtful ways to explore a problem and understand its intricacies and detail. As software developers, it's our job to learn that detail, that qualifies the problem and explains its broad context, and as a consequence, what it is that we want as a solution. This means that making incremental progress in small steps, one of the foundational ideas of my book on software engineering, is an essential part of doing this. So if you are specifying your software in full before you begin, you're doing it wrong. We specify a bit and then we try that out, maybe even as far as releasing it to our users to see what they make of our change and our idea. Then we specify a little bit more and we try that out. In this section, we start to explore nWave's approach to helping with this process of exploration. Let me just see if I can position this. That you've divided the problem into a series of waves that are represented by kind of different agents, different personas that represent that part of the work. And so we're going to then take a fast iterative cycle but reasonably disciplined approach to doing each of these small steps. I think that there are 5, am I remembering correctly, 5 different agents? Could you just tell us what each of the focus of each of those 5?
May I add your point, Ale?
Yes, please.
Of course.
Because your question originally was also asking about the behavioral engineering part. So the behavioral engineering part is indeed the definition of the agent to be solid principle oriented in the specific of S, so single responsibility. The waves are indeed designed to reduce the scope and the boundaries of an agent to a limited amount of freedom. Because in this way, we are scoping the problem to a smaller size where we know after a lot of tests that the probability of hallucination are lower. Then the agent is designed in a way that the boundaries of their personality is standard. So an agent has a name, has a personality trait. We have in the backlog still to implement even the big 5 as personality personas definition. So, but for the moment, what we have is enough to frame the behavior of an agent to represent a real team player in your team with a role and expectation. And this is the secret sauce of the behavioral engineering in nWave. With Ale for nWave Enterprise, we have even brought it to the sky because the orchestration part is designed with an orchestrator that is fully fine-tuned to the user that is using nWave. Because the funny part that a lot of people, they don't get about agentic coding is that at the beginning, your interface is your LLM itself. And if the LLM is not able to orchestrate because wants, for instance, after a context compaction, to deal with the problem instead of keeping that of an orchestrator and is taking that of I am the crafter, then you are screwed. So all this kind of stuff with Ale, we have put in the place. So we have an orchestrator that is boundary frame with behaviors that has to follow, and every compacting is refreshing the behavior of the orchestration, and the agents are designed to reply to the solid principles. So single responsibility, contract in, contract out. We expect this, we expect that as a result. And in this way, we are able to put all the behavioral engineering into the definition of the agents that are a lot more than 5.
On the whole, I like what I've seen of nWave so far. I have tried it on one of my own projects, and I do think it helps to focus us on good small steps. There's a lot to it though, so a lot more to explore. But one of the many things that I find interesting about AI-assisted work and tools is that the AI can help you to learn how to make good use of the tools. I'd summarize the nWave approach as agents as team members. Mike and Alessandro have given many of the agents names and personas and talk about them as though they were teammates. I like that nWave is opinionated. It doesn't force you to work in a particular way, but it has agents and skills that support ways of working that the authors and I think are good. And by default, that's the advice that nWave will offer. Things like hexagonal architecture, deployment pipelines, double loop test-driven development with acceptance test-driven development, and so on, are all built into the approach. In all, at the time when we recorded this, there were 23 agents with more than 90 skills embodied within nWave, but they tell me that there's a lot more to come. Overall, the philosophy is built on the assumption of small steps guided by continuous interaction between human and machine. I'd like to thank Mike and Alessandro for their time and their contribution, and thank you for watching to this point. If you enjoy our stuff here on the Modern Software Engineering channel, please do consider supporting our work by joining our Patreon community. And thanks to our Patreon members for your ongoing support. There's links to that in the description below, as well as links to nWave and other interesting additional reading. Thanks, and see you next time.